That's all wrong. I got you the 17.
You want to hear it?
Draft.
That's what we do.
Try and get out.
Thank you.
Obnoxious.
But Stein, don't put me on YouTube.
Okay, so let's go over what Ms. Hill did here. So, what they gave us a lower bound. They gave us an upper bound, 20 and 25. So I needed to find that point estimate, needed to find X bar. So, how did she find 25 in this case? How did she find 25? She added what?
She added 20 and 30.
So add 20 and 30.
And divide by 2.
So I get 50. And then what? And then divide that number by 2. So I get the 25. So that works. Now, this one you might not have had to because, well, it's 20 and 30. You know the middle of those. It's 25. So you might not have needed to, but just to show the steps, that's why I'm showing this. Okay, so I found 25. Now, what is this here? Why did she do 30 minus 25? What did this find for us?
The upper.
Carter?
The
Upper.
ME.
The ME, what's ME?
Margin of error.
Yeah, found that margin of error. And what was that margin of error in this case?
5.
Yeah, so the margin of error, the distance from here to here, is the 5. She confirmed it by doing the other one, 25 minus 30, even though that'd be -5, which is okay. We're talking about distance.
It was there.
Yeah, that's fine.
Negative. Because.
Yeah, she put 25 minus 30. Not a big deal as long as the absolute value of the number is the same.
Don't mess that up.
So then she wrote confidence interval notation, 25 plus or minus 5. She got 25 from where, Yolanda? From P? The PE, the point estimate, the X bar, plus or minus this. Marcus, what's the 5? Where did the 5 come from? Why did we do this?
Oh, that's the margin of error.
Yes. So, it's the X bar plus or minus the margin of error. Any questions on that? Okay. Now, like you guys are saying, stuff's easy. It's not bad. We've done this before. Something very similar. Let's talk about if we're not given the lower and upper band. So, let's look at number 19. Maybe a little word problem. Take a second. Read number 19. Okay. All right. Number 19. When I read that, they say of a sample size n is drawn from a population that is normally distributed. Why is that sentence important? That very first sentence. Why is that important? It says what? it lets us know that any sample we take is going to be normal, because why? Because our population is normally distributed. So that first sentence is very important. It tells us our population is normally distributed, so we know any sample, regardless of the size, even if it's less than 30, will be normally distributed. So if it's normally distributed, I can draw my bell curve. What is this middle point I drew? What is that? What is the name of that point?
Point estimate.
It's the point estimate. Okay? Also known as the X bar. So when I read the question, does it give me X bar, the sample mean?
Yes.
It does. What is that value?
180.
108. So to give me X bar is 108. What other information did they give me?
The standard deviation.
So standard deviation, they gave me this one.
They gave me the sample one.
So they give me S. And what is S?
10.
10. So, question is, well, Mr. Moran, those are the same. There's nothing different in those. I don't know. But the difference here, the S stands for the sample standard deviation, where this is our population. We talked about that earlier. So, what this means about this data is that it's even more realistic than a section we've done before. You don't need a population standard deviation to calculate this. Because how likely is it to get a population standard deviation without surveying everyone? It's not going to be very likely. So having the sample standard deviation is almost more feasible. Okay? Let's read part A now. Let's see what information they give me in part A. Construct a 96% confidence interval for a mean if the sample size n is 25. So I see n is 25, and what is my confidence interval? The confidence level? 0.96 or 96%. I'll put 0.96. So 0.96, is that the left 96% or the right 96%? It is the middle still. We're dealing with confidence intervals. We're still dealing with confidence intervals. Okay. So 0.96 is this middle percent. How can I find the area to the left? How can I find the area to the right? Ms. Finch? How can I find the area to the left? How can I find the area to the right? No, I don't need to use inverse norm. I know that this is 0.96, and it's in the middle. So yeah, the first thing I need to do is find out how much is left. 1 minus 0.96, and that is 0.04. Okay? And now I take that number and do what? And I'm going to divide it by 2. So it looks like I get 0.02. 0.02. 0.02. Okay. An easy way to check to make sure you have the right information, add these up. They should equal 1. So 0.02 plus 0.96 plus 0.02 should equal 1, and in this case it does. Alright. So they give me this n equal to 25. So if I wanted to use inverse norm, the classic way, I could do area equals, and what I want to do the lower bound first. What's the area to the left?
0.2.
0.02, not a big deal. The mean would be the 108. Remember, that's the X bar. 108. Now they ask for standard deviation. I know I'm going to trick you guys on this. What's the standard deviation for this one? 10. It is not 10. The reason it's not 10, we have a sample size. So anytime we have a sample, we have to calculate a new standard deviation. So let's not worry about inverse norm. The calculator can do it. We talked about it last time. We could find a standard deviation. We could use the standard error of the mean and calculate it. Let's not do it for this case. So, not worried about inverse norm. Let's see what the calculator can do for us. So, I'm back at the home page, back in my calculator. I'm looking at menu. Going back to statistics, number 6. I'm still in confidence intervals, number 6. And I'm still doing t intervals. I still have x bar. So, I hit menu, 6, confidence interval 6, and now I'm going to hit number 2. Now in this case, do I have data like I did for my steps, or do I just have the stats? I just have the stats. I just know what the information is. I don't have the data. So stats. Okay. What is my x bar? 108. That's no biggie. 108. My S of x. What's S of x?
Standard deviation.
The sample standard deviation. So that is 10. Sample size was 25. And my confidence interval was 0.96. So I was given all that information. I hit enter and enter again. And I get all this information. What is C lower again? That's what the value is. C lower is 103, but what is it on this picture?
I know the lower bound.
It's the lower bound. I'm just going to write 103. And what about C upper? 112, but what is it on my picture? My upper bound, 112. Okay? I want to be able to write in confidence interval notation. How can I do that? So, Najee, 108 plus or minus what? 4.2, and you got, did you get 4.2 here? 4.3, yep. So, plus or minus 4.3. And what is 4.3? Like, what is that on here? What do they call it?
Oh, my margin.
It is the margin of error. What is 108?
P. Point estimate.
Whatever he said, I'm going with it. Yeah, point P, whatever. PE. So, PE or X bar. X bar plus or minus that margin of error. Okay, I know we're not master at this yet. But, for today, the homework, we didn't get to it. Don't worry about it. We'll talk.